Hi, this is the notes for linear equations. It's in your ISN, page 42. These are just different ways to write a line. When you think about a line, it is going to exist on an x and y coordinate plane. So x is the horizontal axis, y is the vertical axis, and you are plotting points to create a line on this coordinate plane. So they all have x and y variables, and they're going to be different ways to write linear equations. Well, one we're very familiar with is the slope-intercept form of a line. It looks like y equals mx plus b. We've been working with this a lot, where m is slope and b is the y-intercept. A point slope form of a line looks like this. Y, there's your variable y, minus y1 equals okay. Hi Bighorns, this is Mrs. McNamara with notes for ISN page 32 in your
Hi, this is Mrs. McNamara, and I have, these are the notes for page 42 in your ISN, and it's about linear equations. So linear, remember, we're going to think about a line, and equations mean we are going to be dealing with this line that has x input and y output values. So they're on a coordinate plane. When all else fails, we use a table of values. We pick the x, and we find the y values. There's different ways to write linear equations. So this is the different types of linear equations that you might see. One, we're very familiar with the slope-intercept form of a line, where you have y equals mx plus b, where the slope and the b are the y-intercept, and they could be changing. M represents the slope, and b represents the y-intercept in this case. There's also called a point slope form of a line. That one is going to look like y, that y value, the output, minus y1, which represents a point, equals m, that's the slope, x minus x1. There's your x and y that we're referring to in the line. This is actual point on the line, and m is the slope. Standard form is just another way you're going to see a line written. Ax plus by equals c, where a, b, and c are all integers. Okay. And x and y still represent those coordinates that you find the input and the output on the lines. So let's look a little more closely at these. Slope-intercept formula of a line we've been working with a lot. It is y equals mx plus b, where m is the slope. This is the rise, the vertical change over the run, the horizontal. We also write the formula when we have 2 points, y2 minus y1 over x2 minus x1. This is the formula we can use to find the slope if we're given 2 points. When we look at the y equals mx plus b, slope of a line, we know this is the slope, the steepness, and the direction, and b is the y-intercept, which is where it crosses the y-axis, which means the x-coordinate is equal to 0. So when I want to graph this line, I can identify the slope. It could be an integer or it could be a fraction. M is 1/4. That means it goes up 1 and then it goes over 4. That's the rise over the run. The b is at -3. That means when x is 0, y is -3. That's where I'm going to plot my initial point to graph this line. At the b, when x is 0, y is -3. Now I can use my slope because I know from this point, my y-intercept, I'm going to go up 1 and over 3. Up 1 and over 3. I can go back 1 or down 1 and back 3 if I need another point, and then I can graph this line by connecting the dots. The slope is a positive slope that went up 1 and over 4, and it went through the y-intercept at b equals -3. That's the slope-intercept form of a line. Now the point slope form of a line is new, but it's not, because we know that m, the slope, was going to be this formula where we had y2 minus y1, x2 minus x1. Okay, well, we are going to use those points, x and y, the values that we can pick, and then we're going to use an actual point on the line that we would call x1 and y1. So this is just a formula. Look what they've done. They've taken the denominator and they're going to multiply it by the m, just like when we solve literal equations. So the point slope form of a line, really you have multiplied the slope by this number, x minus x1, and it now equals y minus y1. Well, x and y change in my line, but x1 and y1 is an actual point that is on the line. On the line. So that's how they came up with this point slope formula. You're going to write it actually looks like this. Y minus y1 equals m, that's the slope, x minus x1, where y1 and x1 is an actual point on the line. All right, so let's look at an example here. This might make more sense. There's the 2. That's m. That's the slope of the line. That means I went down 2 and over 1. And these are an actual point of the line. So if I'm looking at this point, x1, y1, because this is now positive, it must have been at the point -1, and it's going to be y was at the point actual 3. Look at the formula. There was a minus sign here. There's a minus sign between the y and the y1. There's a minus sign between the x and the x1. So that means that y must have just been 3, but the x1 must have been a negative to get that positive right there. So the point that this line goes through is -1, 3. So let's find that point on my line. That means that this line went through the point -1, 3. And I know the slope of the line. It goes down 2 and over 1. Down 2 and over 1. Down 2 and over 1. Connect the dots. This is the line when it's written in the point slope formula. Y minus y1 equals the slope times x minus x1. So that's point slope. If you don't get these notes, I have them at the end of this video, and you can pause and rewrite them. Finally, standard form. The standard form of a line is written like a, which is a number, times x, plus b, y, equals c. You can still see x and y are in this equation. That means that x and y are on a coordinate plane and they change. A, b, and c are just integers, so there's not a fraction, and a will be positive. Must be positive. Not will. Must be positive if it's written in this form. So if I look at this line, to graph this line, what you're going to have to do is you're going to have to change it to the point slope form, because then we can graph it. So if it's given to you in any other, like in this form, you're going to have to change it to point slope form. What does that mean? That means you want to isolate the y. We've done this. So if I have 3x minus 2y equal to 8. I've got to move my x term. That means I have to subtract 3x from both sides. Negative 2y equals negative 3x plus 8. 8 is positive, right? And these are not like terms, so I can't simplify it. Then I have to divide by the numerical coefficient in front of the y, so everything gets divided. Each term gets divided. So my equation in point slope form is y equals 3 halves, right? Those two become a positive, x minus 4. There's the slope of my line. It's going to be a positive. I'm going to go up 3 and then run over 2. And it's going to start at my B, my y-intercept, when x is 0, y is negative 4. So I'm going to plot that point when x is 0, y is negative 4. And then I'm going to use my slope. I'm going to run 3 up, and I'm going to go over 2 to find the next point of my line. So I can connect the dots. Oops, a little better than that. And this is going to be the line 3x minus, whoops, this is the line. Let's try this one more time. 3x minus 2y equal to 8. This is that line. All right. Here is the notes. If you miss them, pause this, get the notes into your ISN, and we'll talk more about point slope form tomorrow in class.